do is they're going to tell you how Roman numerals work, and they are going to ask you to translate a bunch of numbers back and forth between Roman numerals and Arabic numerals. So I will tell you what I can. I'll give you what information I can, and what helps me basically whenever I'm looking at Roman numerals. Basically, you've got different letters have different values. So I equals 1, V equals 5, X equals 10. I think L is 50. Yeah. L is 50. C is 100. You can kind of keep that straight by thinking of century. It's been centuries, 100 years. I think D is 500. D is 500. And M is 1,000. Now then, and so, you basically add up values until you get to, if you've got, okay, this is fine if the only numbers you ever want to talk about are 1, 5, 10, 50, 100, 500, or 1,000, but what happens if you want to talk about 37? So you basically, you just divide it into, it's like change. That's not exactly like change either. I was going to say, like, if you hadn't fit 37 cents in your pocket, well, you could have a quarter and you could have a dime and 2 cents. So it's not exactly like that either. But so if you want to represent, you basically represent multiples of those values with multiple symbols. So if you want to talk about 3, well, 3 is I, right? So that's 3. You would think that 4 would be I. And the curious thing is that if you look on a lot of clocks that have their faces denominated in Roman numerals, 4 is I instead of the more proper Roman numeral representation of 4. It's 4 I's, but this is not really proper. So for 4 of really anything, what they do is they do a little bit of math, a little bit of subtraction, and it's actually, I shouldn't say that, I should say 4 is not this, it's actually this, okay? And so the fact that the I appears to the left of the V, it's 1 less than 5, right? So V would be 5, and IV is 1 less than 5 or 4, okay? And that's true of many of the different representations. So for example, 9, okay? 9 is not, it is not VIII, okay? It actually is, no, let's see, I'm getting off the screen there. It actually is, 9 actually is IX, right? So it's 1 less than 10, okay? So the I appears in front of the X, it's 1 less than 10. Now then, there's some other things like you would think, okay, well then I can say 999 by saying IM. No, that's not true. That's and the rules are silly, and I can't keep them all straight. But essentially, those are the things that the thing that you need to keep straight is the fact that you've got this. Like for example, 900. I think 900 is CM. I think 900 can be represented by CM, and the rule lies in the fact that these units are right next to each other. See, but that doesn't make sense with IX because the I and the X are not right next to each other. But so for example, 40 is XL. Okay, so that's 10 in front of 50. Right? So 10 less than 50 is 40, okay? And so like if you wanted to say 44, you would have to use this idea twice. So you've got 10 less than 50, and then 1 less than 5. That's 44, right? Because this is 40, and this is 4, okay? So that's about all I can tell you. On a lot of times you'll see in movies, you'll see like the year 1919. It'll be MCM was 1900. So like the year that I was born is 1964. So that would be 5064. Okay, that's 1964. Okay, and so I don't know a good way to say the rules for Roman numerals. Why don't we start with the 900 in front? Why isn't it CM and then an M? I don't know. But it's the 1000, and then next comes the 900, the CM, and then comes the 50, and this is actually, and the 50 is part of the 60, so this is 60, LX is 60, and then IV is 4. So, use what I'm saying and put it together with what you read in your book, and hopefully you've got a chapter on Roman numerals too, Ethan. But put that together with what you read, and I mean, I actually went and Googled Roman numerals. Not for this. I just happened to do that 2 or 3 months ago. I can't remember why I ran across a question I had about Roman numerals, and I went and Googled it to see, what's like. For example, could you say LD, because D is 500 and L is 50? Is that 450? And it's not. There's only certain combinations of Roman numerals that this applies to, and L and D are not. There's not two of them, but if you read what you have, put it together with what I've said, and you might do some Googling and see if you can find a reliable source on the internet that also says a little something about how you write Roman numerals. God forbid you ever try to do math in Roman numerals. I don't have any idea how that would work out. I can't imagine the torture of trying to do mathematics in Roman numerals. So I think that all you should ever really be asked to do is translate back and forth between Roman numerals and Arabic numerals. Okay, so that's all I'm going to say about Roman numerals. Let's see here. Okay, fractional percents. This is fairly straightforward. You don't have your percent. If we're going to talk about a percent, you don't have to just say like we don't. It's not always going to be an integral percent, right? It's not always going to be just 4% of something, because the world isn't nice and neat like that. So if you talk about the percentage of rainfall that we had this year compared to last year, it's not always going to be just an even number, and so that's okay. We still convert between percentages and decimal numbers the same way. We just divide it by 100, because remember, percentage represents how many parts out of 100 of something we are talking about, right? So if we're talking about he got a salary increase of 50%, that means if you divided his salary by 100 into 100 equal parts, and you took 50 of those parts and added them to his current salary, that's what his new salary is. He got a 50% increase in his salary. Okay, so percentage is just it's an apportioning of some value over 100 equal parts. Okay, and so the way that you convert to decimal is you just divide by 100, because we're saying this is how much per 100th, so we're going to divide by 100. Okay, so if we have, say, 4% of something, 4% of 200. Okay, well, the way that we can change this into a math problem is we can convert this to a decimal, and this of means it's a multiplication problem, right? Can you see that? No, you cannot. Okay, there we go. Right? So 4% of 200 means we're going to change the 4% into a decimal number, and we're going to multiply it by 200. Okay, and the way that we change a percent into a decimal is we divide by 100. And because we are working with a base 10 number system, dividing by 100 just means knocking 2 zeros off the end of a number. Okay, so if we were going to divide 200 by 100, we would just knock those 2 zeros off the end, and that would leave us with 2. But if we're going to divide 4 by 100, we're going to knock 2 zeros off the end of it. Oh, well, there aren't 2 zeros. Well, all we did by knocking those two zeros off is moved here was the decimal point. We didn't have it. We didn't have a decimal point, but it's right there. We just moved the decimal point 2 places to the left. Okay, and we can do that because we're in base 10, right? So if we move the decimal 1 place to the left, we're dividing by 10. If we move the decimal 2 places to the left, we're dividing by 10 to the second power, which is 100. If we move the decimal 3 places to the left, we're dividing by 10 to the third power. So the number of places we move the decimal to the left is the exponent of what we're dividing by, right? So we're dividing by 10, 100, 1,000, 10,000, right? So if we want to divide 4 by 100, we just take the decimal place, which is right there, and we move it 2 places to the left. Okay, so we move it 0.4, 0.04, right? So 0.04 times 200, okay? And the way that we do that is we just multiply, and then we make sure we have the same number of decimal places, or the same number of digits to the right of the decimal place in our answer as we had in our problem, okay? So this is basically just 4 times 2, right? So 4 times 2, and then there's a bunch of zeros. 4 times 2 is 8, okay? And it's actually 4 times 200, so we can call that 800, but we need to make sure that we have two digits to the right of the decimal place, and so we go boink, boink, there we go. So that's 8, okay? And we can do that long ways. Let's do it over here, actually. Okay, so if we do 200 times 0.4, I'm sorry, 0.04, 0, 0, 2 times 4 is 8, and then 0, right? 0, 0, 0. Drop everything. Okay, we count all the digits that are right of the decimal place. 1, 2, there's none up there, so 2 total. Our decimal place is right there in our answer currently. We move it over 2 so that we have 2 digits to the right of the decimal, just like we had up there. Those look like eyes. So that's 8, right? Okay, so there we go. That is how you, and so the same thing applies if you've got something that's not quite so even. If we were saying 4.2% of 200, we just do the same thing. We take this decimal place and we move it 2 to the left. So we end up with 0.042 times 200, right? And so we can do that long ways, right? 200 times 0.042, okay, 004, so 004, and then we come up, we haven't added 0, it's our placeholder, 008, 008, then we have 2 zeros for placeholders, but it doesn't matter because these are all zeros, 0, 0, 0. I add these columns, 4, 8, 0. We've got 1, 2, 3. We've got plus times. We've got 3 digits to the right of the decimal place, and so we need to have that same thing in our answer, 8.4. Okay, so 8.4 would be our answer. Okay, so that's what you do for fractional percents. You treat them just like regular percents. You divide them by 100 to convert them to a decimal equivalent, and then you just multiply or divide depending on what the problem calls for, okay? And so if you run into a problem that involves fractional percents and you don't know exactly how to set it up, give me a holler. Okay, simple interest and compound interest. This is a good life skill to know. So simple interest is it's basically going to be on an annual basis, and it is interest paid on a deposited amount. Okay, so let's say, maybe it's interest charged on a borrowed amount, but let's use the rosy view and say that you've got money deposited with your local credit union, and they're going to pay you 5% interest. Okay, so you've deposited. Well, I need to deposit some ink in my marker. You've deposited $100, and they are going to pay you 5% simple interest, okay? Simple. What that means is at the end of the year, you're going to get 5% on your deposit, okay? So 5% of $100, well, that's $5, right? Because 1% of $100 is $1. If you divide $100 into 100 equal parts, that's $1. So 5 of those parts would be $5, okay? So after 1 year, you're going to get $5. Then, after 2 years, and I don't even understand how this would work, but this is simple interest. You're going to get another, well, not 5%, $5. You're going to get another $5 because it's simple interest, okay? They're paying you interest on your original deposited amount. Now then, I don't know if you've got to go to the credit union and they give you $5 and you walk off with it and go to Dairy Queen or what, or if you turned around right there and said, oh no, I'd like to deposit this, that's probably why no one does simple interest. But this is what simple interest is. It's on an interest on an annual basis, and it's interest on the original deposited amount. Because if they did the normal thing, which is what banks and credit unions the worldwide do now, and they took that interest and they just added it back into your account and then paid you interest on that total amount the next year, that's called compounding, okay? So that's compounded interest, all right? So let's say that's the same situation. You've got $100 at 5%. Compounded, and there will be a compounding period that will be stated. It'll be compounded annually, monthly, semi-annually, continuously. There's a way to figure out continuous compounding. But compounding takes the interest and it adds it back into your principal, and then you're paid interest on the combination. So after 1 year, your balance, let's talk about your balance. Your balance in your account would be the $100 that you initially deposited plus the 5% interest that you earned that year. Oh, and the interest rate is, unless otherwise noted, it's an annual interest rate, okay? So 5% at 1 year is going to be $5. So then they're going to add that $5 into your account. Then after 2 years, instead of them just adding $5 to your account, they're going to add 5% interest on $105, which is going to be, let's see here, that's going to be a little bit of a computation. So let's multiply. So we want to multiply 5%. Can you see that? No, you cannot. Okay, let's move that up. Okay, there we go. So we got 5% of $105, okay? Well, we just figured out how to do that, right? That's going to be 0.05 times 105, right? So, let's see, I'm going to just do this. Okay, compounding annually, monthly, continuously. Oh, you can't even see that either. I need to zoom out. That's what I need to do. There we go. Okay. So I'm going to do this math. 5% of $105. Okay, it's 105 times 0.05. 5 times 5 is 25. Carry our 2. 0 times 5 is 0 plus the 2 that we carried. 1 times 5 is 5. And then everything else is zeros. 0, 0, 0, 0, 0, 0. And we've got 2 digits to the right of the decimal, so we need 2 digits to the right of the decimal there. So $5.25. So at the end of the second year, we're going to have $110.25, right? Whereas with the simple interest, after 2 years, we would only have the $110. So they gypped us out of our 25 cents. Well, they didn't gyp us out of it because we agreed that we were going to open an account with them that paid simple interest. But this is the advantage that compounding has over simple interest. It's the concept that you may have heard of having your money work for you. So as your money gains interest, you are paid interest on the interest. Okay, that's compounding. Okay, now then, if it compounds at any rate other than annually, then what you have to do is you have to divide the rate, the annual rate, into the periods in which it's compounded, and that may sound a little complicated, but for example, if it was going to compound every 6 months, so like semi-annually, every half a year, then what you would do is after 6 months you wouldn't add 5% of your balance into your balance as interest, because that's a whole year's interest. What you would do is you would add half of that. So you would add half of 5%, or you would add 2.5%. 2.5% if your compounding period was semi-annually. If it was monthly, then you would add 1/12 of 5%. Okay, so the percentage rate is generally going to be an annual rate unless they say so, unless it's advertised differently, and the amount of interest that's added at each compounding period depends on what portion or what fraction of a year that compounding period is. So if the compounding period is an entire year, then they're going to add the entire interest. Now, there is, and actually that's not the way interest is paid nowadays. The interest is compounded continuously, and there's a different way of calculating continuously compounded interest. But basically, you get interest added at the end of every day. And they don't figure it based on 1 3. Oh, and that's another thing is, if they were figuring it based on every day, then the number of days in a financial year is generally 360 instead of 365, which is weird, but it probably just makes the math easier. But even that value, the number of years and the number of days in a financial year, for the purposes of accounting and compounding and stuff, even that can be on different financial instruments. It can be specified, it can be variable, it can be 365 days, or it can be 360 days. So, but in interest bearing accounts nowadays, the interest is calculated continuously, but they will give you an equivalent API, annual percentage interest rate. And so the rate that they're advertising is, if we were compounding this annually, this is what it would, this is what the interest rate would be. Okay, but that's a little bit more than what the book is going to tell you. So you got all that extra stuff for free. Basically, what the book goes into is simple interest and compound interest. So simple interest, you're paid interest on your initial deposit, which is called your principal. Your principal, and it's with an AL, not an LE. And you're only paid interest on that principal. Compounded interest is interest paid on your balance, which includes your principal plus any accrued or any acquired or any gained interest up to that point. Okay. So we could say what this would be after 3 years, but then the math gets nasty, because it's gonna be $110.25 plus 5% of $110.25, right? So that math that's long and painful, but that's what it would be. And you can see that obviously 5% of $110.25, which would be compounded interest, is going to be larger than, can you even see this? You can't. Is going to be larger than your simple interest, which would be 5% of $100. We're getting paid interest on this extra $10.25. So that's why compounded interest is a better deal than simple interest. And I don't know of any institution, any situation where simple interest is paid anymore. So, but that's the difference between simple interest and compounded interest. Okay, that's 109 in the Saxon book, and we got one more lesson. Mark up and mark down. Okay, So markup and markdown has to do with really with like the whole the retailing of goods. You know, the sale of goods in a store. We've got the proprietor of a store who gets he gets products at wholesale. So let's call him well, let's just call him the retailer, because the retailer is someone who sells at retail. Retailer buys at wholesale, right? Well, in order to make a profit, you know, he's not going to be in business just because he's doing this to support his family. So he has to take the wholesale price and mark it up. Okay? So the retailer buys at wholesale. The retailer marks up goods. And by markup, that means to mark up means to increase the price. And a good retailer is going to have some sort of formula. They're not just going to kind of willy-nilly mark up their goods, you know, according to the way they feel that day. They are going to have a fairly good idea of what their overhead is. Overhead means the cost of doing business, okay? The cost of being in business, you know, if you've got a store, like a grocery store, say, well, there's certain costs that you're going to have to pay whether you sell any of your groceries or not. So in a month, the electric company doesn't care if you sold any of your bananas or any of your, you know, ham or bread or milk or whatever else you're selling. They don't care if you sold any cans of peas or corn or you know, any of your rutabagas or any of that other stuff. They don't care about that. They just care that you pay your electric bill. Whoever, you know, you're most likely you are renting the space, your building space, from somebody, and they likewise do not care if you have sold any of your groceries. They just want their rent. So those are the costs of doing business. That's called overhead. Okay, so into his markup calculation, the retailer is going to have to consider overhead. Okay, which is the cost of doing business. And then, on top of his overhead, and it's also going to, I mean, part of the overhead is the cost of his goods, all right? So you know, factored into overhead is also, you know, the cost of, I guess, his inventory. That's going to be inventory, right? So how much he paid for it. You know, he's obviously not going to start at zero. He's going to start at whatever he paid for it. That's the cost of his goods. Okay, and then he's going to figure in profit. Okay, and he has to decide what kind of profit is going to be acceptable to him. His profit, remember, his profit has to cover his overhead. It has to cover his, you know, the money that he makes over and above what he pays the electric company, what he pays in rent, what he buys his goods for at wholesale for. Those are costs that he's going to have to pay every month. So he's got to sell a certain amount of goods before he even breaks even. You know, he's in the hole starting out because he's got sunk costs, which means costs that he's going to have to pay. This is basically overhead. He's got sunk costs that he's going to have to pay no matter whether he sells anything or not. So he's got to consider his profit margin into his markup, and so he's got to. So you know, the wise retailer is going to have at least an idea of what percentage of profit he wants to make in order to make his business worthwhile, because you know he's having to spend time away from his family and he's having to put in a certain amount of effort and work to run this operation. He's having to pay employees. He's having to, you know, buy goods and so forth. And so he's got to decide how much profit he wants to make. And if that profit is more than the market will bear, people won't buy his goods and he'll go out of business. And so he has to be very careful about how he calculates his markup. Okay, so markup is going to, and I don't think the chapter is going to cover all this, but it just talks about markup and markdown, and so and it treats them as percentages, okay? And so let's say that a retailer has arrived at, he's decided that his markup on his goods is going to be 120%, okay? And so he buys, say he buys clothing, he buys dresses. He buys dresses at, I think that's the example they use in the book. I'm embarrassed to use the same example, but that's the first thing that came to mind. So let's say he buys dresses. He buys dresses at $50 each. No, that's too much. Who's going to buy a dress that much? $20 each, okay? And he's decided that because of his overhead, his expenses, and how much profit he wants to make on the dresses, he's decided that his markup is going to be 120%. Okay, that means he is going to take each dress and he's going to mark the price up 120%, and before he sells it. So this is the wholesale. Here's the wholesale price. And after he applies the markup, that's going to be the retail price, okay? So 120% of $20, well, remember we take this percentage and we convert it to a decimal by moving the decimal point 2 places to the left. Boink, boink. So we've got 1.2 times 20. That's going to be 0, 0. 2 times 2 is 4. 1 times 2 is 2. That's going to be, because of this, we got one digit to the right of the decimal. We got one digit to the right of the decimal here. Okay, so the markup is $24. Okay, the markup. That's not the how much he sells it for. That's his markup. So in other words, this is how much he tacks on to the wholesale price. Okay, so his retail is going to be the markup plus the wholesale. Okay, so he is going to sell dresses. Maybe he's Dress Barn. He's the owner of Dress Barn. This is retail, okay? So this is wholesale. Can you see all that? Yeah. Plus markup. Whoops. Got those backwards. This is wholesale plus markup, okay? That's what gives you retail. Now then, sometimes he might decide, he might find out that he made a bad decision buying these dresses because nobody's wanting to buy them at $44 because it's an ugly pattern or whatever. It's so yesterday, or there's some reason that these dresses aren't moving at this particular price that he's marked them up to. So he may mark them down, okay? So a mark down is just a reduction in price. It's whenever he decides to put something on sale. Now, that doesn't mean that he's going to sell it for less than he bought it for. Now, he may have to. It would be better, if you bought a bunch of dresses for $20 and nobody was buying them, well, it would be better to sell them for $15 a piece